Hello and welcome to the third exam take-up video for winter 2013. This one will cover questions 5 and 6, which are up on the screen right now. Question 5, Walter uses two inputs, flasks, denoted ZF, and cough syrup, ZC, to produce cleaning powder, which is Y. 100 ounces of cleaning powder requires exactly 200 boxes of cough syrup and one flask, which gets destroyed in the manufacturing process. If these inputs are not combined in this ratio, then there is an excess of one of them, i.e. one of the inputs could be reduced without lowering output. Each box of cough medicine cost him $10, and each flask cost him $200. What is his production function, and what is his long-run average cost? Okay, so if you're from a different section, you can go ahead and try that problem, and I'm going to do the solution right now. Okay, so the first thing we need is a production function, and if you're given a word problem like that, that's always the best place to start, because there's always marks for it, marks production function. In this sort of application, you'll get marks for knowing what you're doing. Okay, so I can't think of a more obvious way to word that this is a minimum function. He used the word exactly, and he used the word if they're not used exactly in this ratio, you can reduce output, or you can reduce the quantity of the excess input without reducing output. Basically, it was what I would consider to be a gimme. Some of you may disagree. Okay, so we're making the production function right now, or at least I am. And it is y equals a minimum of ZC over 200 times ZF. Okay, so now this is, some of you may be objecting that this is the production function for 100 grams of output. I would strongly recommend that you always do it exactly as in the question and then change your cost at the end to reflect cost per gram if you want to. I gave full marks for cost per 100 grams because there's nothing that says that 1 gram of Y needs to be the quantity of output that you choose. It's perfectly reasonable to consider the average cost of producing 100 grams of Y. So anyways, this is our production function. And you'll notice that if we try to plug in some numbers, like if we use the numbers given to us in the question, i.e. ZC equals 200 and ZF equals 1, we'll get exactly 1 unit of output. And if we have an excess of something, so say ZC equals 300 and ZF equals 1, then we still only get the 1 unit, okay, which turns out to be 100 grams. So that's sort of your litmus test for whether your production function works or not, is do you get the right output as per the question when you put in the quantity of inputs. Okay, so we're going to keep going on this, and if you watched the last video, then you know about optimality conditions and feasibility conditions. Right, so this here is our feasibility condition, and our optimality condition is that y equals ZC over 200 and y equals ZF. Okay, now some of you on the test wrote down that MRTS over or MRTS equals W1 over W2. That's the optimality condition for a different production function. Yes, you have to learn more than one. This is how it works for this problem, and you just have to learn it. So now we're going to solve for the conditional input demands, which is so easy on a perfect complements situation. Okay, and we want to know what long run average cost is, right? So LRAC equals variable cost plus, sorry, there is no fixed cost. Short run, total cost over Y, right? And total cost is W1, well, sorry, I'll use the same notation, WF ZF plus WC ZC. Okay, now let's plug in some of our other things. or sorry, the conditional input demands we just solved for, WF y plus WC 200y. Okay. And we're going to divide that by y to get our average cost, right? So LRAC equals WF plus WC times 200, right? I've just divided the y out of both sides. And we know from the question that WF equals 200 and WC equals 10. So our long run average cost is 2200. Okay, and if you're really interested in knowing how much it costs Walter per gram, then we have $2,200, right? And then we said that 1 unit of y was per 100 grams. Okay, so if we want to know what the amount per gram is, we'll just divide through by the 100, and we get that it's $22 per gram, which is what those of you who tried to manipulate the function got as your average cost, which in some cases worked out for you, and in some cases you got the wrong function because you chose to divide by 100 instead of multiplying it by 100. So yeah, that's the answer to number 5, and we'll go back to the question for number 6. A firm produces gravel, Y measured in buckets, using labor. There's basically some mumbo jumbo in the question about there being lots of rocks, so they don't consider them an input. Anyways, there's 2 employees at the firm, Fred and Barney, obviously a Flintstones reference. Each hour of Fred's labor results in 10 buckets of gravel, while each hour of Barney's labor results in 15 buckets of gravel. The firm pays Fred WF per hour of labor, and it pays Barney WB per hour of his labor. What are the firm's conditional input demands and long-run average cost? Okay, so if you're joining us from another section, please pause the video and attempt that problem. The rest of us are going to go on and do the answer. Okay, so start off with, again, we'll start with the production function. This one was not as obviously worded as the last one, but you can usually be pretty safe to say that you had no other question about perfect substitutes on this test. So even if you were just guessing, you should still be able to get that output is 10 times Fred's labor plus 15 times Barney's labor. Okay, so now we have a new optimality condition, and that is that we are going to use only one of the inputs and not both. And which input we use is going to depend on their marginal products and their prices. So it's not all that different from the Cobb-Douglas or diminishing MRTS case, but it's a little different because we're not using both inputs. So even if you wrote down use either ZF or ZB, you got some marks for knowing the optimality condition. The rest of the marks were basically for the production function and knowing how to solve the particular problem. Okay, so if we're using either ZF or ZB, then Y equals either 10 ZF or Y equals 15 ZB. Okay, so we can start with our conditional input demands here. And we can solve this through, and so ZF star equals Y tenths or ZB star equals Y fifteenths. Right, that's supposed to be the denominator. And of course, if ZF star is positive, then ZB star has to be 0, and then in this case, if ZB star is positive, then ZF star has to be 0. Okay, so we've got some conditional input demands. I'm just going to put a big OR in the middle here. And now we have to come up with the conditions that lead us to choose one or the other. Okay, so we've got conditional input demands are that ZB star equals y over 15. I'm just doing this because I want the space back on the left-hand side of the page. I'm just going to write if here because there's that condition that we still have to solve for, and then ZB star equals 0 and ZF star equals y tenths. If, and then the opposite of that condition. Okay? So I mentioned that I wanted this spot back, and I'm going to take it. Okay. So in dollars per unit terms is what I want to think about now, okay? So it's going to cost me WF dollars, okay, per 10 units. All right, I'm getting that right out of the production function. And I'm going to be indifferent between ZF and ZB if my WF units per $10 is equal to, my WF dollars per 10 units is equal to my WB dollars per 15 units. Okay? So I basically want to know which one gives me the lowest marginal cost, right? So, sorry, I should back up a step here, right? This is P Fred over MP Fred, right? And he's going to be indifferent if the marginal cost is the same, right? So P Barney, which we've been calling WB, over MP Barney, right? That's when the firm owner is indifferent between using the two inputs. Okay, but in general, that's not going to be true. It's either going to be, this ratio is going to be violated in one of these ways. Okay? So these are just marginal costs, right? So he's going to choose whichever one gives him the lowest marginal cost. So now let's move one of these fractions over to just give us some ratio of one wage to the other, okay? So let's multiply both sides by 15. Okay? And you'll notice now that this is 3 over 2. Okay, so that's our condition that's going to go in this if here. And now we just need to figure out which one is which. Okay, so remember I said here this was some sort of, well, this was the marginal cost equation, right? So if marginal cost of Fred is less than marginal cost of Barney, use Fred. Okay, so that means that if 3 over 2 WF is less than WB, right? This is the sort of ratio of the marginal costs, right? Then use only Fred. Okay, and we can plug that in where we have the positive ZF. Okay. And then, of course, then if we're going to use Barney, then the opposite must be true. So 3 over 2 WF greater than WB. And that was sufficient for a 10-point answer. But of course, there's always the possibility that they are equal, so you can pick which one you want to make less than or equal to. Didn't have to do that. If you knew how to do all of this, then you probably knew how to do um, the the problem, and I gave you 10 points. But there's also the matter of long run average cost, right? Which is WF ZF plus WB ZB all over Y. Okay, now some of you chose the higher value in both conditions and wrote down that that divided by y was the answer, which is not true because there's two possible values for long run average cost and they follow these same conditions, right? So I'm just going to erase this use only Fred business here. Okay, so if 3 halves WF greater than WB, then LAC equals, right, WF ZF star plus WB ZB star over Y, which equals WF, and right, I come up here to this condition. ZF star is 0 plus WB, and ZB star is Y over 15. Right, and we're dividing that whole thing by Y. Anything times 0 is 0. So 0 over Y plus, and these Y's are going to cancel out, WB over 15. So we'll get that LAC equals WB over 15. Okay? And then similarly for the opposite way of this constraint, right, you can do the same math. Then you'll get that LAC is WF over 10. Okay? So that was the third and second last of these test take-up videos, and I will see you shortly for the last one.